Hey pre-cal students, we're looking at lesson 9.6, not so simple harmonic motion. Okay? So, number one, suppose the length of time between consecutive high tides is approximately 12.5 hours. That's giving us our period. Period is 12.5 hours. In Savannah, Georgia, high tide occurred at 3:30 a.m. on June 28, 1997. Low tide occurred at 9:45 a.m. Depth of the water at high tide was 13.2 feet, and at low tide the depth was 2.2 feet. Make a sketch of the water level as a function of time. So I'm going to let my time equal 0 be midnight. Okay? So t equals 0 is midnight. So my high tide occurs at 3:30 is going to be 3.5 hours after midnight, and it is at 13.2. Okay, this is going to be depth in feet, and the low tide is at 2.2 and occurs at 9:45, 9.75. All right, so 3.5 hours. This is a high tide. 9.75, this is a low tide. So notice that that is 6.25 hours, which is half of 12.5. If I add 12.5 to 3.5, I get 16. So that's my next high tide, which should be evenly spaced here at about 16 here. So I'm going to have a high tide. It's going to come down to a low tide here. And it's going to come back up to a high tide. Sorry, smeared there a little bit. Sorry about that. Okay, and I have one good cycle. That's really all I need here. My B value, my A value, is going to be the max minus the min divided by 2. 13.2 minus 2.2 divided by 2. That's 11 divided by 2 is 5.5. My B is 2 pi divided by 12.5. So I don't have a decimal in the fraction. I'm going to multiply times 10 over 10 here. And 10 times 2 is 20. And 10 times 12.5 will just move that decimal over to 125. Now I'm going to divide top and bottom by 5. And I have 4 pi 25ths. And that's going to be my reduced form of my B. All right? My K value, remember K is your max minus your amplitude. So 13.2 minus 5.5 is going to be 7.7, I think. 7.7. And since the first number they gave me here is, so that would, if I wanted to put it in, 7.7 should be halfway in between these two. And that would be like a horizontal axis in the middle here. Since I'm starting at a maximum here, I'm going to use my cosine to write an equation. I'm going to use cosine. So y equals, I'm going to have cosine. Since I'm starting at a maximum, I know I'm going to use a positive a, 5.5, cosine. And I'm going to say 4 pi 25ths times t minus my shift of 3.5 hours plus 7.7. And that should do it. Okay? So enter the equation. Can you see that okay? There we go. Enter the equation into a graphing calculator answering the following questions. So this is from the last lesson here. Let's clear all that out. So 5.5 cosine 4 pi divided by 25ths times parentheses, I'm going to do x instead of t, minus 3.5, got to close two parentheses, plus 7.7. All right, for my window, I'm going to go from 0 to 16. Actually, let's go and make it 20, just expand it just a little bit past that 0. Going by ones should be okay. I can go from 0 for my y scale. I'm going to go from 0, something above 13.2. Let's go up to 15 maybe. Go by ones there as well, and that should work okay. All right, so we should be able to see the whole thing. We'll get a little bit more. So here's our 3.5 hours, and here's our next peak at 16 right there. Halfway in between will be our 9.75 over here. All right, when did the next high tide occur? Well, we know that that was 3.5 plus the 12.5. And that's how we got the 16. 16 hours after midnight. Or 4 p.m. Okay? On 6/28. What was the water level at 11 p.m. on that day? So that would have been 23 hours later. And so that's not even in my window here. So let's expand a little bit. Let's make this 25. And let's graph that. So what I want is for t equals 23 hours here. It's finishing graphing. And so one way to do this, I mean, you can go into the regular calculator. We can go over here and plug it into my equation. But pretty easy on the calculator, I can do second trace number 1, ask for the value, and I can put it in an x value like 23, and it'll give me the y value I want, which in this case is 2.586. 2.586 feet. So it's pretty close to the minimum at that point, it looks like. After 23 hours, we're pretty close to a minimum. In fact, you can see it marks right there. And if I want more numbers for x, I can just, I don't have to keep on typing second trace 1. I can just put, if I want 5, I can press enter. 9, I can press enter. 12, I can press enter. And I can get whatever I want. Okay? On to the back. Since the number of hours of sunlight in a day cycles annually, it can be modeled with the sinusoidal function. Longest day of the year occurs on the summer solstice, while the shortest day of the year occurs on the winter solstice. In Boston, the number of hours of sunlight on the summer solstice is 15.283, and on the winter solstice, day 355, there are 9.067 hours of sunlight. Okay, so make a sketch of the hours of sunlight per day for Boston. All right, so I've got summer solstice. I have 15.283. Didn't write that very well. 15.283 right here on the summer solstice. Day 355, winter solstice. I'm going to get 9.067. And then evenly spaced out, my next summer solstice should be about right here. And that's back at my maximum again. Okay? So, this will look like something like that. Write an equation to model this one. All right, the only number I have on my x-axis is this 355, so that's what I've got to use, and since that's a minimum, I'm going to use my cosine. So for my amplitude, I'm going to say 15.283 minus 9.067 divided by 2. I don't know what we get there. 15.283 minus 9.067, and then I'm going to divide that by 2, and I got 3.108. Since I'm starting at a minimum, I know I'm going to have a negative 3.108. Okay. For my B value, I know that it's going to, my period is 1 year. 2 pi over 365, right? It's going to keep repeating every year. It's going to repeat. Cosine of 2 pi over 365. And then I'm going to say t minus 355 plus my k value is going to be 15.283 minus 3.108. 15.283 minus 3.108, and I get 12.175. All right, so there we go. We have an equation. We've got our graph. Enter the function to a graphing calculator. Answer the following questions. All right, let's get it in here. So let's clear this out. Negative 3.108 cosine 2 pi divided by 365 times, we'll open a new parentheses here, x minus 365. No, excuse me, 355 for my shift. Double parentheses to close, plus 12.175. All right, for my window, let's go on and show like 2 years here just in case. Well, it's asking for, no, I don't need that much. I need just 1 year. Let's put in like 400, 0 to 400. And we'll go by 50s for the scale. They'll put a mark every 50. And then 0 to 20 should be pretty good, I think, for the Ymin to Ymax. So at the beginning, in January, this is January 1st, that's, or close to it, I guess. That's pretty close to the bottom, shortest time of the year. How many hours of sunlight were there on day 263? So second trace, number 1, I'm going to put in 263, and I get 12.215. 12.215 hours on September 20th. March 1st, how about let's put in 60. I get 11.063. Y'all see this here? 11.063 hours. And when are there at least 12 hours of sunlight to the nearest day? Okay. So I'm going to go back to my y equals. I'm going to put in 12 hours of sunlight. So I want at least 12 hours of sunlight. So I'm going to find this intersection to the left, this intersection to the right, and all those days in between there, I get 12 hours or more days of sunlight. So second, trace 5, intersect, and I'm going to find the one to the left first. And we're going to round to the nearest day here. Press enter 3 times, and I get about day 78. So between day 78 and second trace 5, I'm going to move my cursor closer to the one on the right. That's pretty close. And I press enter, 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 and I get 267. Between days 278 and 267 should be it. Okay? All right. Let me know if you have any questions. I know this is slightly more complicated because now we have k values involved. That's the main thing, and that's the main difference here. Okay? So let me know if you have any questions about that. I'll talk to you later. Bye-bye.